Okay, my angels, here we go. Forces tutorial. What I want to do, I'll talk about the written section first. I'll try and give you some hints as to the multiple choice. The written section is 3 or 4 questions. Can't remember. Photocopied this a while ago. But I can tell you certainly which questions are fair game. First of all, lawnmower questions. In fact, I think the very first written question is a lawnmower question, I think. What do I mean by a lawnmower question? Oh, something like this. And I'll change the numbers here. So, where we have horizontal acceleration, but an angled force. Well, really, a lawnmower question is when we have a normal force that doesn't really equal mg. So I'm going to make a brand new question. Was there one like this in the big review? Has anybody gotten this far? There was? There was? So I'm going to make this, how about 33 kilograms? How about 31 degrees? And we'll have her apply a force of 180 newtons. So she's been working out a little bit. And the friction force acting on the... You know what? Instead of me giving you the friction force, I'm going to say that mu equals... Do some quick back of the envelope math, Mr. Dueck. Friction is what times what, mu times the number, I don't know the number 4, so look at another force, same size as the number 4. So it's going to be 35 times 9.8 minus... Okay, yeah, that'll work. Mu equals 0.12. Okay. What will be the horizontal acceleration of the bale? First of all, I could say draw the free body. In fact, you know what? Why not? Part A, draw the free body diagram. And heck, I'll even give you 2 marks for that. This might be, there will be at least somewhere on the written where I ask you to draw a free body diagram. And if I ask you to draw a free body diagram, although you can still label the diagram above, I really mean in the space below, draw a free body diagram. So, what are the forces acting on this hay bale? Get the obvious one. Get the obvious one, for the love of God, please. Gravity. This is participation, my children. What else? Well, there's an applied force. What else? Normal force. Why would I mark this wrong? And I would. Well, let me make it a little clearer. Why would I mark this wrong? I have no idea what you said. I think it's supposed to be the same size as gravity. Why would I mark it wrong if it was the same size as gravity? There is a vertical component right there. So if I gave you this question, I would be looking for a normal force that was smaller. Also, why would I mark this wrong? What force is causing this guy to accelerate? Not the applied force, no. Otherwise, it would be moving up and away and diagonally, would it not? Fx. Now, on my picture, by the way, you'll notice, Rachel, I don't put components on a free body diagram. That's the... Sorry. This is the correct free body diagram. But reason I wouldn't accept a long friction force is the winner better be that puppy right there, which, based on how I've drawn it, is that big. Now, Again, I don't put components on a free body diagram. There would be the free body diagram. And if I was marking this, I would look for a normal force that was clearly smaller. What if, instead of tugging up, what if we were pushing down? What would that do to the normal force? And I'd be looking for a normal force that was clearly bigger. Oh, and maybe even a friction. Oh, what if it said that this didn't move at all? What if she's tugging and I say that it doesn't move? Then what can you tell me if that's Fx? What can you tell me about the friction force? Exactly the same. So lots I could ask if I was being nitpicky about a free body diagram. Anyhow, there's the one for this particular situation. And then I would say for part B, find acceleration. Now, I'm going to shrink this down so we can try and get more of this on one page. My apologies to those of you in the back, but I'll try and read stuff out. In fact, I'll probably find, you know what? Let's move part B right there, and then I can work next to the drawing at least and you guys can see it. I would probably label my drawing. So I would say I got mg down, normal force up, friction. I would break up the applied into Fx, and don't put the Fy there, Mr. Dueck, and Fy, something like that. Mark, can you see that okay back there? Is that large enough? I can go a little bigger, maybe. Let's try that. Okay. What does it want me to find? The acceleration. So I need to write an equation. Which way is this thing accelerating? Who's winning? So if I was marking this, I would give you a mark if I saw winner minus, who's losing? That would get you a mark. Absolutely. Now we have to get tricky. Fx, well, that's adjacent hypotenuse. Oh, this was one situation where Fy was sine, conveniently enough. So Fx is going to be the applied force times the cosine of theta minus friction is what times what? Okay. Now, in most of these questions, Ty, we solved for friction on a separate line. Somewhere else, we said, okay, let's go find friction. Let's see. Can you write me a vertical force equation? Can you write a vertical force equation? Are we sinking into the ground like quicksand? Are we flying into you like Superman? So everything out cancels out, everything up cancels out everything down. So can you write me a vertical force equation? Everything up equals everything down. What force or forces are down? What force or forces are up? So I guess the normal force, which I need to find friction, is going to be mg takeaway Fy. By the way, if we were pushing downwards, Fy wouldn't be pointing up. Fy would be pointing down. It would be on the right-hand side of the equation, and you'd have mg plus Fy, which means normal force would be bigger, friction would be bigger. It might not move. Stupid, but doable. Okay, which is going to be mg minus the applied, I think Fy is sine theta. Now, I could plug that in there. How would I get the A by itself? Divided by m. I'm not going to walk through all those steps. I'm going to say I think you guys could take it from here. Mixing and matching, how can I muck around with this? Other options. Freeze the screen. Pause the recording. Other ways that we're live now, Mr. Dueck. Unfreeze the screen. Haha. Instead of giving you mu, the coefficient of friction, I could tell you that the block isn't moving. So let's try the same question. Same diagram, or do I have a different diagram that might work? I'm trying to find nice, pretty diagrams because my diagrams, when I freehand them, suck. Please show me another lawnmower question here, Mr. D. Otherwise, you're going to go back to that one. No, it's close, but not quite. Your lawnmower? No? Okay. This is the old review that I used to give out, by the way. So let's take this question here. Oh, heck, let's make it 190 newtons. And if I tell you, and I say to you, okay, friction equals what times what? Why won't that work here? Sorry? I can't hear. It's not moving. No, that would it would still work. There's something else. I can find the normal force. There's something else I haven't told you. What's mu? I haven't told you what mu is. In fact, a part B or C for this might be, tell me what the minimum coefficient of friction has to be for this not to be moving. So, how might I start out? Really? How have I started out every other time? Let's label. I label my forces here. So, okay, what are the forces acting on this puppy? I have gravity down. I have a smaller normal force. I'm not, since this isn't a free body diagram, I'm not freaking out about trying to beat a scale because I'm not receiving marks for this. I have the applied. I have friction. And I guess I'm going to break this up into Fx and Fy. Can you write me an equation that includes friction? Taking use of that. Grant. This is kind of strange, but yeah, I guess I can find friction without mu. In fact, it's going to be the applied cos the angle, I guess. 190 cos 28. A little strange. What did I find in A? Hey, is there an equation that has mu and friction in it? I don't know the normal force. Well, first of all, let's get the mu by itself. So I guess mu would be friction divided by the normal force. I don't know the normal force. And I'm not going to say, look. I know another force the same size as the normal force. I am going to say, look. Is this bale sinking into the ground like quicksand? Is it flying into the air like Superman? Then everything up has to equal everything down. Can you write me a vertical force equation? Oh, in fact, it's the same as we just wrote. First of all, I think you would say everything up equals everything down. So you would say, okay, Mr. Dueck, everything up, which is the normal force and Fy, equals everything down. And now you can get this by itself and plug it into there, plug that answer into there. Sure, that would be, I mean, that's a B plus A minus level question, but that all comes out of the lawnmower. I think that's about it. Not moving or accelerating. If it's not moving, hey, what's mu? I don't know what's... Oh, by the way, I guess going back to your point, I could also, if there was an acceleration, still, if I told you the acceleration, you could find the friction force, because if there was an acceleration, it would be, this equation right here. So to get the friction force by itself, I'm pointing, people at home don't know what I'm talking about. This right here, I could plus friction over minus MA over, and I would know all that, and I could solve for friction that way too. This was a little more convenient. So lawnmower question, totally fair game. What else? Ramp question, totally fair game. Totally fair game. Not only fair game, I think I'm going to ask you to do something with the ramp question. So here's a ramp. That's a terrible drawing. I can do a little better than that. Not much, though. Shut up. Okay, there's my ramp. Hey, there's theta, our generic theta. And let's have the block accelerating down. Okay? So, first of all, obviously I can say, find the acceleration. How? Oh, let's say, you guys like numbers, don't you? So let's make theta 38 degrees, and let's say that mu equals 0.19, and let's say that m equals 12.6 kilograms. Thank you. Okay. Suggestions? What else? What else? Which way friction? Up the ramp. What if it was sliding up the ramp? Which way would friction be? Down the ramp. Okay. A possible way that I could tweak this question. I'm trying to think of options. Friction. There's the free body diagram. Now I would actually break gravity up into mg perpendicular and mg parallel. Which way is this block accelerating? So I need to write a down the ramp equation. Down the ramp is winning. mg parallel is in the winning direction. Are there any other forces down the ramp in the winning direction? Nope. Any forces in the opposite direction? Any losers? Okay, mg parallel. I can do something with that, can't I? Oh, you're saying it's going to be sine? Oh, that's kind of convenient. Minus mu times the normal force equals ma. I don't know the normal force. Oh, but look. Another force the same size as the normal force. Which one? What do I do with that mg perpendicular? Of course I do. Okay. So it's going to be mg sine theta minus mu mg cos theta equals... Oh! Did I need to give you the mass, Shaq? By the way, if you're not sure whether the masses cancel and they don't give you a mass, make up a reasonable number. Don't use 1. 2 is a good one, or 5, or 10. I always avoid using 1s because when you multiply by 1, it doesn't change the answer, and I might think something canceled when it actually didn't cancel. But if you're scared, make up a reasonable number. Now, you notice, Emma, I'm trying to push you algebraically. I'm nudging you into the wonderful world of abstract logic and algebra and all, and that's kind of cool, kind of good. But we're doing the best we can. Oh, so A is going to be g sine theta minus mu g cos theta. Now, what else? I could give you A and say find what's mu. I don't know what's mu with you. Okay, I could tell you the acceleration. Or more likely, first of all, somewhere on the written, I'm going to ask you to find a mu. Somewhere. That's a nice little twist. I've done a bunch of those on the quizzes, so hopefully that's not too big a surprise. Or somewhere I'm going to ask you to find A. No, I'm going to ask you to do something with A. So I would have no problem giving you this picture, but instead of saying find the acceleration or find the distance after 4.5 seconds, or V final, or V initial if I give you V final, or, in other words, bringing in some of the kinematics stuff, Rachel, from last unit. Okay? The only thing you have to be careful of is you do need to ask as soon as you start going to unit 1, am I slowing down or speeding up? Because if I'm slowing down, what do I have to do with the acceleration? Got to make it negative. Okay? Because that was vector land. Here, hopefully by the end of this unit now, I've convinced you why, Josh, it's so much more convenient to let the winner be positive, whichever direction that is, because it makes the math much cleaner, right? Okay? So you can definitely expect a ramp somewhere. You can definitely expect an Atwood machine somewhere. Either giving you both masses, find acceleration, find tension, or giving you the acceleration or the tension and one mass, and saying find the acceleration or the tension and the mystery mass. If you were finding or solving the mystery mass, that was where we pulled a little grade 9 mathematical operation out of our back pocket. And so I'll do one of each. I'll just freehand this. Atwood machine, 8.4 kilograms, 5.1 kilograms. Find the tension. Although I said find the tension, you know what I'm going to have to find first? The acceleration. Do I know both masses? Then I can write an equation for both masses. Let's see. M1G. But by the way, what if I said write the free body diagram for that left-hand mass? What are the forces acting on that 5.1? Get the obvious one. What's the other force? If I said draw the free body diagram, would I draw tension bigger, smaller, or the same size as mg? Convince me. Which way is mass 1 accelerating? Up, down, or is it at rest? Up, and it's accelerating, not at a constant speed. It's going to be accelerating. So that means the bigger force must be pointing which way? So if I asked you to draw the free body diagram, I would definitely look for tension to be bigger in this case. Anyways, they said find tension, but I'm going to start out by finding acceleration, looking at both masses, and then look at one mass to find tension. So look, M2G. But the reason I said that is we're really sloppy on this labeling the forces, because you'll notice I'm putting the tension arrow just kind of there. I'm not really being cautious as to whether it's higher or lower, a bit further than mg or not. I'm really not being that fussy. Who's winning? What's the equation? M2G minus tension plus tension. Every time you do that, smile when you cross out the tensions. It helps you relax on the test. What else? Minus M1G equals what? So the acceleration is going to be M2G minus M1G all over M1 plus M2. 8.4 times 9.8 minus 5.1 times 9.8 all over 5.1 plus 8.4. I would trundle off to my trusty calculator. By the way, again, common mistakes I see on the test, yeah, leave that out. It's not that important. Thank you. I see that all the time, and I don't know why. I see a times instead of a plus. Don't do that. 2 point. Oh, what did they ask me to find, Anthony? So this is not my final answer. I'll carry some extra sig figs. I'll go 2.3956. How can I find tension, Anthony? Show up late in my class. That's one way, Grant, but there's another way to find tension. Mathematically, we can find tension. When you show up late for my class, that's called experiencing tension, but that's not finding tension. Just saying. How can I find tension, Anthony? I have no idea. Winner, loser? More specific. You want to use M1? Why? Oh, because tension's the winner there, and they're both nice, clean forces. Bear with me for 1 second.
Good job, Tom.
Right click. You said use mass 1? Yeah, and it really doesn't matter, but often one will be easier. Tension minus M1G equals what, Anthony? So how would I get the tension by itself? And stick that in there. I'll let you crunch it yourself. I'll assume you're okay with that line. Hey, what if I gave you only one mass? Okay. Or, so still an Atwood machine. And suppose I told you that tension was equal to 190 newtons. Find mass 1. Okay. Any thoughts? Find acceleration. How? Any more thoughts? You're right, by the way, but I think you may have seen what we're supposed to do. More blatant, more obvious, more basic. Yeah, let's label everything first, right? How could I find acceleration? Did they give me both masses? No. So should I try doing a both mass equation? Then let's try writing a one mass equation. Which one? How about the mass that they gave me? Oh, who's winning? You know what? You can find out in a hurry. Because what is M2G? It's going to be 14 times what? 9.8. What? How about in our heads as a shortcut, Emma, 14 times 10? Mg on the right is around 140. A little less. What did I say tension was? 109. By the way, you saw me doing some math in my head. That's what I was doing. So, you know what? In this case, I don't need to guess. Who's winning? Tension. Barely, but tension's winning. If not, I'd guess, and you know how I would guess wrong? You know how I would know that I'd guessed wrong? What would my acceleration be? Negative, go back and fix it quickly. And usually it's a pretty quick fix. But here, I can guess right. I can say tension is the winner, M2G is the loser, M2A. Do the masses cancel? Oh, what did you say I wanted to find, Darian? Because you were right. Oh, how would I get the A by itself? It's going to be 190 minus 14 times 9.8 divided by 14. I was trying to make up something that really didn't accelerate very fast. Yeah, there you go. 3.7714. I'll go 3. You know what? I'll go 3.7714. Actually, I'm going to use the answer button on my calculator. But since they said find mass 1, not acceleration, then, Rach, I'll just carry some extra sig figs, right? Now let's go find mass 1. You can make it, Shaq? Look a little tired. You sure? Hey, folks, what's my equation for mass 1? Who's winning? Sorry, who is winning on the right-hand side? So which way is mass 2 accelerating, up or down? So which way is mass 1 accelerating? So now, who's winning? How many M1s do I have? 2. How many would I prefer? 1. Hey, let's get them to the same side. Plus the tension over, minus that over. If I do that, I'll have change colors, Mr. D. M1G minus M1A equals tension. Check. How many M1s do I have? 2. How many would I prefer? 1. It'd be wonderful if there was a little grade 9 mathematical operation that I could reach into my back pocket, pull out, and it would suddenly turn this from 2 to 1. There is. GCF, by the way, that's a great trick, and I think those of you that are in pre-calc will also be using that often in the log unit, which I think you're just starting, if I'm not mistaken, this year. Trust me. So factor out on M. I guess M1 is going to be tension divided by G minus A. It's going to be 190 divided by 9.8 minus 3.7714. Some of you just have to have answers, so I'll crunch it. 190 divided by 9.8 minus answer button. 31.5 kilos. So Atwood machine, yes. Ramp, yes. Lawnmower, yes. Atwood machine with a ramp, also fair game. I think, you know what? I think out of those 4, I think I picked 3 on the written. I think. So third possibility for written, ramp at an angle with a pulley hanging over a cliff. Something like, please tell me I have one in here. Sort of like that, although, oh, you know what? This is actually tougher. Instead of hanging over a cliff, we've got some friction. That's going to add some extra forces, because if you're hanging over a cliff, all you have is tension and mg. Here, it looks like I'm going to have tension and friction. Friction is what times what mu times. Okay, this is going to be a little trickier. This was a 7 marker from years ago. I probably included this one in your forces review, so I'll change the numbers just in case. Apparently, this was the first written question the year that it came out on the provincial exam, right? They got, you know what? I'm going to go like this. They have everything in the drawing itself, and that's going to allow me to keep this big enough so that the people at the back can see it. So I'm just going to go, in fact, I don't need to say find the acceleration. Let's do that. So here is an Atwood machine, 2 masses with a pulley. Oh, and a ramp. And in this case, friction too. Cool. Yoink. Yoink. Did I make friction bigger or smaller? I better make this mass bigger to make sure it moves, because I might have made friction too big. So you know what? How about 22 kilograms? I think I'll be safe there. I did some quick... I made the angle steeper, so that means gravity is going to be pulling downwards in a straighter line. I think I'm okay. By the way, an A-plus question, if you wanted, would be this with a missing mass, find a mass. I would consider that an A-plus level question. That'd be pretty tough. Okay. Anyways, to show it's frictionless, we often will put wheels, or I'll say it's frictionless. So frictionless here. Find the acceleration. Is there any way that it's accelerating up and left? Because there's no unbalanced outside force to the left. It could be at rest if I find out that friction is so big that it's able to hold this in place, and I'll find out if when I solve for acceleration I get a negative answer, then I'll sheepishly apologize to you for doing some bad math in my head. Or it's sliding down the hill and to the right. Talk me through this. Any suggestions? Sorry? Okay. What are the forces on mass 1? Get the obvious one. mg. What else? Ooh, been a while since I've been able to do a straight up and down normal force. No pun intended. What else? What else? Got a rope. I think that's everything. What are the forces acting on mass 2? Get the obvious one. What else? Normal force, which is going to go like that, right? What else? I heard it there, I thought. Tension. What else? I think that's it. But I can't solve yet. If I'm going to solve this, I would break this up into M2G perpendicular. Boy, let me try that again. I don't like having stuff inside the triangle. That just confuses me. M2G perpendicular and M2G parallel. And for this to be moving, what has to be bigger than what for this to be accelerating? Can you see it? Ashley, this one here had better be bigger than friction, otherwise we ain't moving anywhere. So, if we're lucky, who's winning? Hope so. So anything that ends up pointing down the ramp is a winner. Now I'm going to walk not along the ramp, along the rope, which for a while will be on the ramp, and then for a while will be horizontal. This one here, loser. This one here. This one here. A lot of kids want to put this one in this equation. No. That's a vertical. It's not along the rope. It is going to show up indirectly in a second. But right now that's going to be equals the mass of both times A. Yay. Okay. M2G parallel. Oh yeah. M2G sine. Friction is what times what? I don't know the normal force. Oh, but look. Oh! Grayson, friction is what times what? Mu times the normal force. I don't know the normal force. Oh, but look. I know another force the same size as the normal force. Which one? We're over here, kiddo?
Over there.
Yep. Yeah. We can't say, you know what? I should call it M1, shouldn't I? Good point. And that's where the mg showed up. Equals, Grayson, do you mind? Can I divide by both masses here to get the A by itself? Because I'm gonna. Could we go from there? Sure. In case you want to try this at home, the answer is going to be really, really quickly, Mr. Dueck. How about you do that without covering up everything? M2, 9.8 times sine 51 minus mu 0.32 times 15 times 9.8, close bracket, divided by bracket. 22 plus 15 is 37, right? I hope. 3.26. Hey, now that I know the acceleration, what else could I ask? Tension, sure. V final, V initial, all this. I mean, once you have acceleration, the sky's the limit. Probably for one this tricky, I might give you just find the acceleration. Certainly, Rachel, if this wasn't on wheels, if there was friction on the right-hand mass, I think find A and I'd quit, because that's a lot of work. Okay, but these were both on wheels. I'd say find A for part A, and then part B, find the tension or find something else. So that's the written section. Now, looking at how I can mix and match stuff, look at the two quizzes. So I know, for example, on the second quiz, I think I had you find mu a couple of times. That's fair game on a ramp. It means working your way backwards, but okay, what's mu? I don't know. What's mu with you? That works. Were there any specific questions, either from the homework or a specific type of question, or from the review that you were wondering about that you would like me to go over? Now is your chance to ask. And don't pack up yet, because I'm also going to tell you which questions I like from my big review. Emma?
Number 3
From quiz 1? Sure thing. Did I give you quiz 1 version 1 or version 2? What does it say at the top of the page?
2.
Version 2? Quiz 1 version 2? This one here? So 3A and B?
No, it's
3A? Okay. I need the diagram, so I'm going to go like this. And then I'm cleverly going to go here 3. Like that. Hey, I got it all on one page. Good enough. So that is changed to 60 newtons. And now there is a mu of 0.12 between both of these masses. Is that right? Okay. Any thoughts on how we're going to start? Sure thing. Let's start on the left-hand mass. What are the forces acting on this 10 kilogram mass 1? Get the obvious one. I'll call it M1G. What else? I'll call it normal force number 1. What else? What else? There's one more we're missing. Sorry? Friction, yep. I'll call it friction force number 1 to go with mass number 1. You're going to be up in a little bit, so be ready. This is your moment to shine again, right? What are the forces acting on mass 2? Get the obvious one. Normal force number 2. The applied force. Tension. I'm missing one more. Yeah, force. Don't forget friction force 2. Boy, that looks like it's pointing into the ground. I can do better than that, but not much. Apparently I can't. Friction force number 2. Is that okay? Which way do you think this system is moving? Sure, I should be careful, by the way. Which way do you think this system is accelerating? So who's winning? Good call. Winner. Okay, let's walk along the rope, Emma. The next force I run into is this one. Winner or loser? Yep. Sorry, I just can't hear, and I can't see your mouth move your lips, so I'm having to hear. By the way, your voice is coming right over the fan of my projector, so it's getting all wonky. Keep going. Minus what or plus what? Minus friction 2. Keep going. Right here. Winner or loser? Winner? Right? I know, it's a long day. And then, winner or loser? Friction force 1. Yep. Do we have forces from more than one mass? Do we have forces from more than one mass in my equation? Then I better have more than one mass on this side of my equation, right? Hey, Emma, to quote Aaron Rodgers, RELAX. The football guys got that. How would I get the A by itself? Okay. Are you ready? Are you ready? We're coming. We're coming. Can you feel the anticipation? Divided. Okay, so if I hear you correctly, you're saying A is going to be this whole thing divided by that, right? Which is going to be the applied, which I think I said was 60. Yeah. 60 minus friction force 2 is going to be what times what? Mu times the? I don't know the normal force, but in this case, what's the normal force equal to? Sorry, I just saw a total disappointed face. Fine. I don't know the normal force. Oh, but look. I know another force the same size as the normal force. What? I didn't do the full look. By the way, hopefully you're cluing why I do that stupid thing now, right? I'm really telling you, you better look. Minus mu m1g. That should get you there. Can you take it the rest of the way yourself? Cool. Any others? Then if you look at your review, really? You want the comma there? Okay. Questions that I really like. Let me get the review. Questions that I really like. I like number 1, I like number 1, I like number 1. Number 2 is good. 3 is good. I really like number 6. Seven is good. Eight is good, and 8 you're finding mu, although 8 to me is a little easy because everything's horizontal. I really like number 10. There's a classic lawnmower question. Number 13, there's a classic lawnmower question. That to me is physics 12. 14, there's finding mu on a ramp. That's more fair game to me. Sure, 17, that's a physics 12 question. That's finding an acceleration, and that gives you an idea. Oh, in fact, that's very similar to the one we did where I just changed the numbers. I mean, 19 is good, but 19 is too easy in my mind. 21. Although, I'll be honest, looking at 21, so 21 says find the magnitude of the friction force. I would almost certainly say find mu, which is one extra step, because once you know friction is what times what, mu times the normal force. I don't know the normal force. You can find mu. So I would probably, in number 21, actually take it one step further. '24 is good. 26 is good. Atwood machine with some frictional component. You're going to have to do the whole thing anyways, whoever said no more. 31 is good, although, again, 31 has a ramp and a block stationary on it, so it's not accelerating, it's not moving. It says find the force of friction. I would probably say, well, look, if you can find the force of friction, I kind of want to know what's the minimum coefficient of friction that could be holding this block in place. .33 elevator question, absolutely. 34, there's a good ramp question. So for the scholarship section, I think 36 is totally fair game. 36 has one mass with friction on a ramp and another mass hanging in the air. I've given you stuff that tough. They give you mu. They give you the coefficient of friction. They're saying find the acceleration of the 8 kilogram block. Actually, you're going to find the acceleration of the whole thing because that is the acceleration of the 8 kilogram block. And again, I would argue, to me, I've gone a little bit of advance with you. 38, although it's scholarship, it's asking you to find the coefficient of friction on a ramp, which to me is fair game. There's a key phrase in 38. It says the box is moving up the incline at a... That helps an awful lot. Part B, that's a little trickier because now you're transferring mass from one to the other, making it a brand new question. But certainly 38A, I consider that not just fair game. The fact that it's a constant speed makes it way nicer, actually, I think. And yeah, 39 to me is totally fair game. It's a scholarship, totally fair game. Okay. Any other questions at all? Then I'm going to pause the video and then I'll see who would like me to print a copy. Just give me 1 second.